We have already discussed Ethernet LAN is the most popularly used protocol in the data link layer. Now we are discussing about the frame format of the Ethernet. So here IEEE 802.3 they designed a format. That format we are discussing now. Block of data which we are sending, that block of data we are calling as a frame. From network layer packets into data link layer frames, from data link layer frames to physical layer bits. This is how the data flow is there from the source end. In the destination end, from physical layer bits to data link layer frames, from data link layer frames to network layer packets, network layer packets to transport layer segments. This is the data flow. We are using coaxial cable for the physical transmission. Now we are discussing about the frame format. In this frame format, first we are using the preamble. In this preamble we have 7 bytes of information. These 56 bits are alternatively ones and zeros. So 10, 10, 10, 10 we are using. So this alternative 10, 10, 10, these are 56 bits, means 28 ones and 28 zeros are coming. This is indicating that source is trying to send a indication to receiver, information is coming, be in synchronization. For the synchronization between the source station and the destination station, preamble is very much important for the signal synchronization. After the preamble, in the data frame format, we are using start frame delimiter. So in this, we are using 1 byte information. 6 bits are alternative ones and zeros. Finally, it is ending with 1, 1. This series of 1, 1 is indicating that this is the last chance. Like in aeroport, when we go to the airport, they will announce, dear passengers, this is the last call. They will call by name. Some particular passenger ABC, you have not boarded. This is the final call for you. And after that, the flight will take off. Similarly, here we are saying this start frame delimiter. It will indicate that this is the last chance for the synchronization. After this, there will be no communication for synchronization. You have to be ready to take the data. Okay, this is what we are calling as start frame delimiter. And you can almost these two are acting like a similar kind of bunch. So these two are related to physical layer. And then we are indicating the destination address in the 6 bytes. This destination address where the frames have to go. This destination address is nothing but a physical network interface card information. In this network interface card, we have some address. Now, if this address is matching with this address, then the data will be processed further. If the address is not matching, then the data immediately it will be rejected. Next, source address. From where it is coming, that source address will be indicated here in the 6 bytes. And the length of the data. This is whether what type of data you are sending here, whether you are sending document or image or video or audio. And if you are sending the data, what is the length of the data? That length you can indicate here. Means each frame length. Whatever the frame you are sending here, that data frame length here we are indicating. Finally, the data frame, this is our original data. To send this data, we are adding all these. Why we have to add all these? Because correctly the data has to go. This is how the engineers think. This is the data, only we have to send this part only. But in order to send this part, we are saying to receiver, now the data we are sending, get ready. And again we are giving final call to the receiver. And we are sending from where this is coming, from where it has to go, and from where it is coming, what is the length, and then we are sending our data. After sending out that, it is like we are indicating when some guests comes to our home, we are saying from where they are coming. Example, they are coming from Hyderabad, they are coming from Delhi. So we will think if they are coming from Delhi, okay, they have to come to airport, we have to go there to receive them. Similarly, some kind of arrangements we will make. And similarly, length, if they are coming 2 members, okay, we can arrange something. Suddenly they are coming some 50 members or 100 members or 1000 members or 2000 members, means that then according to that we have to make the arrangements. Similarly here, the length we are indicating, whatever the length, accordingly here in the network interface card, accordingly we will allocate the space. Now the data frame length will be generally 46 to 1500 bytes. Sir, what if the data is less than 46 bytes? My data is only 40 bytes. No problem. We will add zeros. And then we will transmit it. Then we will send the frame check sequence, FCS. It is a code. It will check whether there is an error in the data or not. When it will check at the receiving side. If the checksum that was calculated at the transmitting side and the receiving side both are same, then there is no error in the data. But if the checksum calculated at the receiving end is different, then there is an error. We can detect that error. And finally, it is indicating that end of the frame. The frame is ended. Again, you can send the next frame. Here we have discussed the frame format. It is very simple to understand. First, we are giving the preamble. 56 bits of data we are sending, 7 bytes. Alternative ones and zeros. Next, start frame delimiter. We are sending, this is a 1 byte data, 10, 10, 10, and finally 11. This is the last indication for the synchronization. And then what is the destination address, what is the source address, what is the length of the data, and the data we are sending, and error detection code we are sending. This is the end of the frame. That's how IEEE 802.3 defines the frame format.